I know, yeah. So, class, let's go with it. Let me pause. Let's go. So, chapter 6 is called equations. Yep, that's exactly what we're going to do. So, all the stuff that we've done so far in chapter 5 was there to help us. All those formulas we got, right? All those. That's all that was. So, we might run into an equation that needs a double angle formula. We might run into an equation that needs a half angle formula. We might then come into an equation that needs to add angles together first.
It's like the natural continuation of what we just did.
Yeah, except we're going to be solving.
Yeah.
And then there's one little kind of interesting glitch here. Not a glitch, but interesting thing with this stuff. So if you want to put in 6.1. 6.1, solving trigonometric equations, the beginning. All right, then what we probably should do, we're just going to review just a quick few algebra concepts before we begin. So this is pre-beginning.
Beginning.
Okay, we're good. So before we do that, let's jump. I think Back to the Future, but no, it's just back to algebra. So back to algebra, here we go. And simple stuff. First things first, we know we solve equations. We have the addition property of equality. It just means this. I can add two things to both sides of an equation. Like Mr. Ng, I know that. That's been something I know how to do ever since, like, what, 3rd grade?
I don't know. I wasn't really thinking.
Okay. 7th grade, okay. Technically pre-algebra was 7th grade, right? But do you guys remember moving blocks to one side of the equation, signs the other, right? All right, and the multiplication property, I can multiply both sides by the same number of the equation, or technically I would divide, right? So dividing by 3, technically is still multiplying by 1/3, right? And the funny thing is, the reason why it does not have a subtraction property, the reason why it does not have a division property, is because in pure mathematics, there's only multiplication and addition. So subtraction is just adding a negative. And multiplication really is just multiplying by the reciprocal.
Interesting.
So
subtraction and division are just derivatives of addition.
Pure mathematics, yeah. Cool. Well, we're good. First one on the list, you should be able to solve for x. We're back to this.
Oh my god, I'm excited.
All day, right? Okay, 3 problems here, just real quick here, and then we'll jump into the trigonometry section. All right, so first things first, what I would do, if you're waiting for me, I would subtract 3x from both sides. I usually just try to get my x's together first. Cool, good. Awesome, yep. Usually people are like, oh, finally, I can fuse things together that I know. All right, how about subtract 6 from both sides? We good there?
Yep.
And then we divide by 12. And then whenever we have fractions, we try to simplify them as much as possible. So how about a negative 2/3? Are we good there? Cool, all right. Thumbs up, we're good. All right, and then we had, so the next level up from here was something called factoring. Is that right? Mm-hmm. So if we have something set up like this, and tell me if you need to go back or not. If you have something set up like this. Oh, cool.
Why were you doing this last time?
Because I was helping my sister with her math, but I was doing it the long way to calculate the math.
Mm-hmm.
So I did the Pythagorean theorem.
So did you guys do the, let's see. Yeah, we'll get there in just a second. This one, the little X box over here on the side, right? What we do is we put the -8 on top. We put the -2 in the bottom. And the question is, what two numbers multiply to -8? And add to -2. Yep, -4 and a +2. Or you could have just wrote 2 and -4.
I've never seen that.
Oh, really?
It is much easier for me in a box.
Gotcha. Okay, yeah.
Well, but I also I did algebra 1, geometry, and algebra 2 online.
Mm-hmm.
So it's like I didn't have a teacher.
Gotcha. Okay. Shit. Oh, learned it yourself here. That's super cool.
Essentially, yes.
And then x will be 4 and negative 2.
So we have negative 4 and 2. So then we go x minus 4 is one parenthesis or one factor. X plus 2 is another factor. And then we have something called the zero product property. It says if two things are multiplying to give you 0, what you can do is you can set them each individually equal to 0. Put a little or in there. And then solve them individually here. So if I add 4 to both sides, I get x equals 4. And over here, I subtract 2 from both sides. You get x equals negative 2. All right, and here's the interesting thing is it's a conceptual thing. You guys ready? So notice at first we do an or statement, right? To solve, if two things are set equal to 0, either that one could be 0 or that one could be 0. All right, so if this was a physics problem and we were talking about time, which one would we discard? Yeah, the negative 2 goes away, right? Because that's not even an answer, right? If
It happened in the past, so it's negative time.
But if it's not, if it's just a regular O problem here, you can accept both answers. So application questions, usually if with time, we get rid of negatives. If we don't think it happened in the past, except if you're in the quantum field. But let's do that. Okay, the other part is, let's see. And sometimes these would not work for trigonometry. We'll see when, okay? So go from there. Okay, so then the next one, this is called the factoring equation. This is called the quadratic formula.
Me too.
If you did forget the quadratic formula and you're like, okay, what is the quadratic formula? Let me give it to you. And anybody want to sing the song?
Minus the square root of b squared minus y is equal to
I'm so sad no one doing it now. Everyone here do it. Everyone.
All right, and let's solve the problem here. Let's see if you guys haven't done so already. I think most of you guys are done, or some of you guys are done here. Let's see. A, B, and C are the numbers in front of x squared, x and no x, respectively. And then we plug it in. So negative b plus or minus the square root of b squared, which is 4, minus 4 times the 2 that's in front, which is the a value, times the negative 1 in the back, which is negative 1, over 2 times the a value again, which is 2. So how about negative 2 plus or minus? And I got myself, let's see, that's going to be 8. Negative 8, subtracting negative 8 is a positive 8, so 4 plus 8 is 12. Are we okay with 12? Over 4. Done. And do you still need the calculator section? Yeah, All right, and we got ourselves, let's see, root of 12, right? Root of 12 is 4 times 3. And 4 is a perfect square of 2's. And so therefore, it's going to be 2 root over still 4. And then the fun trick is this. You think about division now. So, no problem. The division is this. Right over there. Pick it up right.
Plus. We're not doing 14, 15.
Correct, yeah.
So it would be negative 2 or plus or minus.
It's going to be the division. It's going to be a number that goes into this 2 here, goes into this 2 here, and also goes into the 4. What should we divide by? By 2. So that becomes a negative 1. That becomes a 1. And that becomes a 2. That's funny. Okay, we're okay with negative 1. Let's see, plus or minus. And then 1 times root 3 is just root 3? Over 2. Regina, if you got that before me?
Wait, I have a question.
Boom, boom. Okay.
How are you able to just cancel out the 2 if it's multiplied by the root?
Does it?
Sure.
Does it get divided by 2?
Because technically what you can do, so Caitlin's question is, why can you just divide this out? Because you would technically factor out a 2 first out of these numbers, put it in front, and then you reduce it. But this is the quick way of doing it.
Okay, that makes sense.
Okay, now to trigonometry.
This is where it gets tricky.
Very tricky. It's been tricky all year long, but now it's going to be super tricky.
It's going to be
So real quick here, just so you guys remember, so all the stuff we learned in chapter 5 applies. We good? All right, just to note real quick here, those are two different answers, right? We have a positive answer. We also have a negative answer, right? Not so much a positive negative answer, but we have an addition answer and we have a subtraction answer, right? So just don't forget there's two answers that are sitting here. Okay, let's begin. So solve a simple trigonometric equation. Let's go for it. There's two parts to each of these. So the first part is going to solve for all degrees. The second part, your book says solve from 0 to 360. Now, real quick here, that we're going to do it. We're always going to solve for b first because that's the way it just logically progresses. I'm not sure why the book wanted it this way.
On the test, you would switch it around, like saying.
On the test, I'll either give you one or the other. I'm going to say solve for all degrees, or say I'm going to solve between 0 and 360. Now, these guys are in degrees. What's the other angle measurement we used? Radians. So I could say solve between 0 and 2 pi, right? Also note, look at this. Note that it says from 0 degrees is equal to theta, right? When you get to 360, it's not equal to theta. So we don't include the 360. We don't include that. It's just one loop around, but not including the beginning anymore. We good? So let's jam. Let's go with it. Here it is. Here's your question to answer. Go.
What?
I need to solve for theta
So,
if 2 cosine theta minus 1 equals 0.
so you could use the double angle?
It's not squared, right? It should be 2 cosine squared theta minus 1.
Oh, really?
This is the easy one, though.
Oh, you just.
What are you going to do?
Yeah.
Let's go with solve for cosine theta. How about just add 1 to both sides? You good?
Theta equals cosine theta. 1/2? Shoot.
Good there? And then we're going to do this. We're going to divide by 2, and we get cosine theta is equal to 1/2. Now, the only thing that we got to be careful here is this. We're not using cosine inverse, right? In the way of just finding one answer, right? We're not using cosine inverse as a function. Are we good? We're going to use cosine inverse as a way to get back to my whole entire unit circle. We good? So in this case, we think to yourself, when does cosine, on the unit circle, when does cosine give you 1/2? When does that happen? Oh, I heard 60 degrees, right? So you're looking on a unit circle, if you have one. And how many would like to get one? Yep, you guys should have. Almost there, almost there.
Another unit circle. I gave you one already.
Then I gave it back.
No, I had an extra one.
Because this is how I store all my math papers.
That's how I store all my math papers. I keep track of them. It's not a good excuse.
Some of us are better at organization than others.
What?
So,
All right, I heard 60 degrees on the unit circle. Is there any other? And also 300 here. So I got 60 degrees on my hands, and I got myself 300 on my hands. Perfecto. So real quick here, that is the answer to B. So between 0 and 360, there are two answers. And the answers are 60 degrees and 300 degrees. We have finished part B of the assignment.
Oh, just a ship is one.
You just, all you have to do is find where on the unit circle.
You have an x coordinate of 1/2. Of a positive 1/2. Say again?
I understand it now.
You know, I know why.
Say again?
But
Talk to me, because I do want to answer the question. Why do we do it? Because we're solving trigonometric equations. We have solved the equation. We've solved what theta will be plugged into cosine times 2 minus 1. That would give us a 0. Okay? So then, guys, here's the concept question. Here's this. Now, cosine will go around and around the unit circle. Is that right? It'll go, I can do a whole revolution one more time, right? If I do a whole 360 from here, I will hit the 1/2 again. Is that right? How many times will I do that? An infinite amount of times. We good? Yeah. So we're gonna do this here. We're gonna say this. Give me all the solutions in the whole entire world forever and ever. So if I start listing them, it'll take us forever and ever. So we have to make up some kind of quick little equation here. So we're going to say 60 degrees plus 360k. And here is we get to define what k is. You get to define what k is. K is an integer. So notice if k is 0, is that right? Let's take a look at this one here. If k is 0, we get ourselves 60 degrees. Are we good? If k is 1, what degrees are we sitting at? Bless you. If k is 1, what degree are we sitting at? 420. Yeah, it's just one loop around the circle, right? And then 60 more. Cool. Okay, we found the 60. What's the other one that we found? The 300 one, is that right? So 300 plus another revolution called 360k. Now you don't have to define k again because you have already defined it once and you're good to go. We good? That's it. So
That's the answer you just write.
yeah, that answer for A is all the degree solutions in the world. We good? And answer for B is just 60 and 300.
But that's how you write.
That's how you write. Yeah, that's how you write.
You write K as an integer?
K is an integer.
Okay.
Now, you could define k as, we're going to mostly define as an integer, right? You could also define as an odd integer. You can define as an even integer, right? We get to choose how we want to define k. All right. Essentially, that's it. The only thing that gets complicated is we might have to factor. The only thing that gets complicated, we might have to use the quadratic formula. And the only thing on top of that, it gets complicated is we might have to recognize like, oh, that's a double angle formula. I could use this. Or I could use this identity to change things around. We good? Essentially, that is chapter 6.
What is this useful for?
Cool.
I can take the test right now.
Uh-huh.
Could you?
I believe in holding.
Sure.
I believe in holding as well.
It is used whenever we have anything that is going to cycle back and forth. So if you have a piston in a car, a piston goes up and down in a car, right? That makes the car move. If I want to know, like over here, if it moves according to 2 cosine theta minus 1, that's how fast it moves. I want to know the initial position of that, right? And so anything that cycles, we have a way to get a formula. And then when it equals something, you want to say, hey, equal to what, 20 feet up or 3 millimeters, right, displaced, or anything else like that. We're good? So just like algebra, solving equations is, you guys solved algebra equations for like a height of something, right? Right? Something goes up and then it comes down. When is it 32 feet up in the air, right? So now this one is, if something is going up and down, right? Or the, like even the moon itself, right? We see the moon on the full moon, right? We see 100% of it, right? And it goes down to 0 and we get the new moon, right? And so it cycles. So anything in our world that cycles, we can solve by trigonometry. And if you want to know the exact value, like, hey, I want to know when it's right here, we use trigonometric equations. We're good? And we'll do some applications in the textbook as well on those. But essentially, it's anything that cycles. We got ourselves a way to solve. All right, and the next one on the list. Zoomp. Where are we at? Here, and I think we're here, right? Zoomp. Yep. Oof, there it is.
Well,
Now it's cotangent. So careful with the cotangent, but be good. Let's do this one together as well. But I think, you guys can go ahead of me just a little bit here. Say again. I go with it, yep. So the easy stuff is you add 1, just like we did in the last one. You add 1. This time we're going to divide by √3. And we got ourselves cotangent is 1 over √3. Now the question is, on the unit circle, when does that happen? Perfecto. So let's kind of write things out if we need to. Almost all the unit circle, actually no, all of them have a denominator of 2, is that right? Let's kind of think through this here. So that means if I make this into coordinates on the unit circle, I'm going to just put in for the top, which being a 1, now changes into 1/2. The √3 on the bottom changes into a √3 over 2. Now the other thing that we got to think about is this. So I want my x value to be this. It happens when? It happens at, yeah. So notice all these guys, if you're looking at your unit circle, right? Notice all your denominators are 2s, right? That's what we wanted to do. We want to get all of them to be denominators of 2. All right, and by definition, this has to be the x value, this is the y value. So as you go around your unit circle, what angle measurement between 0 and 360 gives you? X coordinate of 1/2 and a y coordinate of root 3 over 2. Yes, awesome. Okay, so I got myself this one right here, which is 60. And then with fractions, here's a little sneaky thing here. Remember, if you did have originally 2 negatives there, right? The negatives would cancel, right? And give you 2 positives. So got to think about if these guys were both negatives, what would be the angle measurement? That's the only sneaky thing about cotangent and tangent. It would be 240. Are we okay there? Look at your 240 angle. See if that makes sense. Garrett?
Okay, so with the 1 over root 3, you just, the 1 become sine of this changes cosine sine.
It's going to be cosine over sine. Yeah. Uh-huh.
And then you just, okay.
We're good? Yeah. And don't forget, you can have a positive positive. You can have a negative negative. Those will both give you the same ratios. Megan? Question? Oh, yeah. No, 6 degrees is just because you have an x coordinate being 1/2 and a y coordinate being root 3 over 2.
You said, it seems like you're saying 240 over 60.
Oh, gotcha. No. 60 degrees is one answer, and then 240 is the other answer. Okay, how do we write it up?
So, theta equals 60, theta equals 240.
Perfect. Yeah. If you want to write these on your notes, that's fine. If you have a over b, it's the same thing as having a negative a over negative b, right? If you want to have those for your notes. Just kind of note that for tangent and cotangent, those are needed. Yeah. If you have a fraction that is both positive, both positive. Don't forget the fact that they could also have been both negative before the negatives disappeared on you. So that gives us the 40 answer. Okay, and so for B, which we do first, my answers are theta is equal to 60 and 240. What is my A answer? Perfect. Yeah, and you can write it like this as well. You can write it 60 degrees plus 360k, comma, 240 degrees plus 360k, where k is an integer. Okay, and then the funny thing is with tangent and cotangent. Tell me if this works here. Notice that 60 degrees and 240, they are exactly half a rotation away, aren't they?
Wait, what?
So if you look at 60 degrees on your unit circle, right? Looking at 60 degrees on your unit circle and then looking at 240. Aren't they exactly half of a circle away from each other?
Yeah. So you can start at 60 degrees.
So here to here. So you could start out, perfect, yeah, you could start off 60 degrees plus 180. Does that make sense? And if you add another 180, would you get back to 60?
Yes.
Add another 80, would you get up to 240 again, right? And then you just keep on going and going and going. So here's a little shortcut. The shortcut way of answering this. This is the way Bob likes to answer it. He was going to do this. He's going to say 60 plus 180k. Are we good? Where k is an integer.
But does it matter which one it is?
Does not matter. Just as long as when you look in the back of the book and Bob says 60 plus 180k, but you had 60 plus 360 and 240 plus 360, you know that's the same thing. Okay, we good there? Does that make sense to you guys? All right, let's get a little bit more complicated. Not by much, just a little bit more complicated. On your mark, get set, and... All right. Solve this one. All right, so now let's see. I changed it to t instead of theta, just to give you guys different flavor for the angle. Next thing is I changed it from degrees to radians. So now notice instead of 0 degrees to 360, now I got myself 0 to 2 pi. So your answer has to be in radian measurement. All right, next thing is on the equation itself. Hey, I got sine on both sides here. All right, so what should we do here in order to solve for sine of t?
I subtracted 3 sine t for both sides and subtracted a square root of 3 from this.
Okay, did it a little bit the long way. That's fine, because I'm thinking this. If I already have the root 3 already on the left side sitting there, is it possible just to subtract the 5t from both sides?
Yeah, but
And
I
you're-
like the other way 'cause it's
That's why.
it keeps it positive and
Yeah.
make my brain.
Yeah, that's fine. Yeah, either way is just fine here. I got myself this. Now I have to divide by -2. And then what I do here, I just switch it around. So sine of t is equal to a negative root 3 over 2. Okay, oh, nice. Okay, this is our sine function. So along your unit circle, from 0 to 2 pi, using radian measurements, give me the angle measurement that makes that happen.
240 and 300.
Oh, no.
30. Oh, no.
But it's negative.
Mm-hmm.
4, 5.
210.
No.
What the frick?
Wait, why is it not gradient solutions?
4 pi over 3 and 5 pi over 3.
Oh! I was like, wait a second.
So t is equal to 4 pi over 3 and 5 pi over 3. Are we good there? Because we are in radian measurement, that's why. Okay, that's the B answer. What's the A answer?
4 pi over 3 plus 2
Yeah.
pi.
14 and 15 for extra credit.
No, I'm going to take them off the test completely.
Wait, are they extra credit if you already spent significant time on them?
Sorry, guys. No, I just had to take them off the test because I messed up on it.
Would it be 4 pi over 3
I
plus 2
know.
pi
But it
k
was,
when k is an integer? Okay.
So it's going to be 4 pi over 3 plus 2 pi k. Remember, 2 pi is what you weigh around the unit circle, right? Angle measurement. So you just stick a k next to it. 5 pi over 3 plus 2 pi k. Or k is an integer again. Integer, yeah. Let's see, whole numbers as well as negative of those, right? So
And 0.
0, 1, 2, 3, yeah, but also -1, -2, -3, -4. Because you remember you can spin backwards as well, right? You can go to the negative angles. Okay, are we good
Do you
there?
have to write t equals, or can you just write 4 pi over 3 plus 2 pi k?
The correct way of doing it is t equals, but if you just write 4 pi over 3,
Did you t equals for the other ones?
I didn't, no.
So
So either way is just fine. As long as you're understanding what you're talking about, it's fine.
okay.
The precise technical way of doing it should be naming the variable and saying what it equals, yeah. So t equals should be the precise way of doing it. All right, that was A, that was B. I think we're good with that one here. Next is, dun, 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 dun. You might just have to use a calculator. Let's see. Go with this one. Solve for all degree solutions. Oh, back to degrees now. And we go from 0 to 360, but it says use a calculator and round to the nearest 10th of a degree. So let's go with it here.
And my brain can do it instead.
That's going to be a tough one. And here's our problem here. Solve this one. Whoa.
You draw something, guy.
All right.
There's no way this calculator is also dead.
Do you want to use mine?
I'm-
What do you mean you're okay? I have extra.
Oh, okay. Yeah. I didn't want to like take your calculator that you were using.
I have an extra one.
Okay.
It's not a graphing calculator, but we don't need it graphing.
That's minus the negative 3.
That's fine, as long as we kind of try to do it together here. All right, class, let's go with it. Let's do the algebra part of it though first. How we would solve for sine of sine of theta.
Minus 3 divided by 1.
Perfect. How about in your own mind, minus 3 divided by 4, it gives you a negative 3/4 because you guys are cool like that. You can do it 2 steps in one time. Cool, okay, so we're looking for the sine value to be negative 3/4. So let's take a look at this here. Do you guys remember if you're going to do by calculator, right? First things first is we forget about the negative in the first place. We forget about the negative. Yeah, we do. Because all we want to figure out what is the reference angle. So make sure you guys are in degree mode on the calculator. And what you're going to punch into your calculator is you're going to punch in you're going to find actually theta hat. We want to find just the reference angle only. So sine inverse of a positive 3/4, what is that? To the nearest 10. So if I were to draw it in angle 1, I don't think so, not 36.
7.3.
48.5.
I go with that. So on the calculator, you should get something about like, what is it?
48.6.
I go with 48.6. 48.6 here. So if you guys did not get that, I'm going to walk around real quick here just to make sure we got it here. Yeah, sure, because you're not trying to find the ratio. This is not an angle. This is the ratio already, and you're trying to get backwards back to your angle. So we have a reference angle of 48.6 degrees. So just real quick here, I'm going to walk around real quick here. I just want to make sure that you guys get 48.6 degrees in your calculator if you tried it. As long as you know that. Cosine's going to be the problem. If you put in a negative into it, it's going to give you the wrong answer.
For like 5 years, it was never that.
So it's good just to put in the positive and be done. Right? So reference angle's good. Let me walk around. So raise your hand if you didn't get 48.6. How about that?
So theta hat is 48.6.
Yeah, so that's our reference angle in quadrant.
I got 4.86.
Minus 46 to get what's actually
Bombini Lucini versus Bombini Crocodilo. Bombino Crocodilo. Bombino Crocodilo versus Bombini Lucini versus Tralalero Tralala.
Let's go with it. We got 48.6. Which quadrants are we supposed to be looking at, though? Which quadrants are we looking at? When is sine a negative value? When is sine quadrant 3 and quadrant? No. 4. I'm looking for things in quadrants 3 and 4.
Wait, because it's the y value, that's why.
Yeah, it's the y value. Remember, sine is the y value, and the y value has to be below the x-axis. So, if you go from reference angle to angle, remember doing that, guys?
Yeah.
Reference angle to angle. In quadrant 3, do you subtract or do you add? And what do you do in quadrant 3?
So you add 180 to in quadrant.
Yes. Yeah. If you're in quadrant 3, remember, notice you're half a circle already ahead, right? So you're at 180. You're at 180, and then you're still supposed to add another 48.6. For quadrant 4, what do you do?
What is it, minus 360? It's 360 minus 30.
Perfect. Yeah, it's 360 minus theta. You're almost at a full entire rotation, but then you subtract it out. So that's perfect. So let's go with it here. So can you guys calculate on calculator? Give me quadrant 3. I think it's 180 plus 48.6. Answer is
228.6.
to 8.6, perfect. And then quadrant 4, you're 48.6 degrees shy of 360.
311.
Perfecto. 311.4 degrees and to 8.6 degrees. Are we good there?
Oh, it doesn't matter what order you.
Does not matter what order you put it in. Perfect. Good question on that one. All right. Are we still jamming? Are we still good? All right. That is the B answer. Is that right? What's the A answer? So all yours to write out the A answer.
2 by K.
Not too high.
360.
Oh, I know that. That's what you meant. I totally
It's the
understand.
same thing. It's basically
No.
All right, and we go with that's the A answer, and I got that's the B answer, and there's my A answer.
Yes.
When K is an integer, just to make sure you guys are paying attention.
Okay.
All right. This is what do you guys say? Pretty fun.
Yeah.
Chapter 6, pretty fun. 6.1.
No, this is.
What's your home?
I missed algebra. I forgot.
6.1 is pretty fun.
Dr. Seuss.
Kind of banging, bro.
All right, let's jam with the next one here. How about this? Solve so you guys try it and see what you guys come up with. The problem is, here's your problem. All right, go for it and see what you guys get there with.
What? Hey,
What?
this is not being nice.
What?
That's over 1.
Perfect. Okay, so if you subtract sine theta both sides, right? That's what I did. Or you could have added 2. That's fine. Then divide by -3 on both sides. And we get ourselves the sine theta is equal to 4/3.
Okay, that's what I thought.
Perfecto. And then when does sine theta give you 4/3 on the unit circle? Never. Okay, so here it is. Here's one of those where you have to say that's greater than 1. Therefore, there is no answer. There's no solution to this one. So this is a fun one where sometimes theoretically, sometimes practically speaking, right? You'll ask an engineer or something to build something, right? Like, hey, I want this much torque towards the end of something. And they'll calculate it and they'll say, sorry, you're not going to get that much power.
If you like took
For
the
this.
circle and like button it out, that's 1.
Would it be 2?
Unhooked it and like
It'll be 2 pi, right? Because that's circumference,
so
right?
how come 1 is the like threshold for
Yeah, because the y value, right? The y value can only reach up 1 on the unit circle, right? Can't go above 1 on the unit
is it
circle,
1 and -1?
Oh, it hit.
right? Yeah, because the sign value. That's no problem. There's a lot of stuff in chapter 6. You guys will sort of have those moments like, oh, now I get trigonometry. Okay. Yes, this is a no solution problem. You're going to get some no solution answers on your homework. We good? Next one. Factoring. Here we go. Factoring, here we go. So now, some people will say, oh, Mr. NG, look at this. 2 sine x, cosine x, that's the double angle formula for sine. That's great, but I don't want to use the double angle formula for sine. Actually, I want to go backwards on it. If this was a double angle formula for sine, right, I would undo it so it becomes a single, right? That's the whole point of of using those identities to make it actually more. So instead of making it more complicated, making it a double angle formula, right? You want to bring things back to single angles for the most part.
Do you convert the sine into a cosine?
So does that mean?
I'm thinking this here. I'm thinking you have cosines in both of those terms.
Yeah.
Aren't both those terms equal to 0?
Yeah.
Can I factor out a cosine x?
Yes.
Let's factor out. I'm going to take a cosine of x out of this.
Even though it's double angle, we just ignore it.
Yeah, don't use double angles. You want to get double angles back to single angles. So I got this. Are we good with this one, guys? We are factoring out a cosine of x.
I like factoring.
Here, what we do is we want to factor out the cosine of x, especially since it's equal to 0. I'm going to split this off into individual pieces. So notice another interesting problem is that I have way too many trig functions, right? I have to some kind of isolate them to be individualized.
Could you also subtract the cosine from both sides and then divide by cosine?
No, because you can't divide by any of your, like you won't be able to, in algebra you never divided by x or so, right? So same thing here, you can't divide by your own variable. So here it is, how we individuate each of the trig functions is, we usually do it by factoring. Now notice what I'm doing. As I'm trying to figure out when cosine is equal to 0, I can do that. I'm also trying to figure out when is 1 minus 2 sine equals 0. If I do this real quick here, subtract 1 divided by 2. Everybody okay with the 1/2? So now notice by factoring, what I did is I made individual pieces for my trig functions. Now I can take a look at the unit circle and find out when those things happen. Anybody know when does cosine of x equals 0?
Pi over 2.
Perfect. Yeah, pi over 2 and 3 pi over 2, since we're in radian measurement. Perfect. When does sine give you a 1/2?
Pi over 3. Pi over 6. 5 pi over 6.
Pi over 3 and 5 pi over 2.
No.
Sine is going to be the
y.
y. Yes, sine is going to be the y value, right? You're looking for the y value to be a 1/2. Pi over 6 and 5 over 6. Okay. And Bob, since he's kind of cool like that, he likes to write them always in lower to higher order, right? But you don't have to do that because they could be in any order. Okay, good? So the B answer to this one is those 4 answers right there, right? If you want to write them out, so it would be B answer is 1 pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. I did not write in order. I'm not as cool as Bob. And then what we do is we write all the answers. So we got to go pi over 2 plus, oh, you know what I can do? I can kind of combine these guys together. Aren't they exactly half a rotation away from each other?
Yeah.
So instead of writing pi over 2 plus 2 pi k and then 3 pi over 2 plus 2 pi k, I can combine these and just say pi over 2 plus pi k. But these guys I'd have to do it individually because they're not half a circle away from each other. These guys, pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k make full rotations, and I got to declare what in the world is k? K is an integer.
But you can write it all out if you don't want to simplify it.
Correct, yeah. You can write it all out. This is the way probably Bob would write the answer as well. I'll accept both answers on the test. There's no problem. Let's see. Integers. Fractions are integers, right? But integers are not fractions. Right? But yeah, integers can't be fractions. Yeah, so integers can't be fractions. Whoa.
Effort.
You guys okay?
Effort made.
Whoa. You okay?
Sorry.
Yeah.
Oh, you want this back also?
Yeah. That's fine. Yeah.
Effort made.
Effort made.
What?
Did something with that.
Okay, class. Let's see. And we've got a couple more. Let's see if we can do one more here. Yeah, I guess we should go with the quadratic formula example. Yeah, okay, boom, and all right, class, one more time. Here it is. The quadratic formula example. So Maddie and Lily just came in towards the most difficult question of the day.
The video. I will watch Khan Academy.
So let's go with it. The quadratic formula. Notice first things first. Notice that all
With the 2 and the 2 and the negative 1?
I don't know.
The first one, it wasn't cosine, but we did it.
Bloop bloop is good. Let's go with it here. Let's see. We got a minute and a half left. Yeah, let's go. So I got cosine. Oh, notice what I have is it's not x, right? It's cosine theta equals negative b plus or minus the square root of b squared, which is 4 minus 4 times a times. I wonder.
Familiar.
It is so looks familiar.
I've seen this one.
And if you guys go back on your notes, where do we put this one? What was the answer? Sorry. What was the answer to this one? From our, it was that. Negative 1 plus or minus root 3 over 2. Is that right? Okay, cool. So now from here, now we got to do this here. Let's take a look at this here. We're putting everything together. So question is this. If I were to take, use your calculators here, take negative 1 plus root 3, set it say equal to, and then divide it by 2. Will that give you a number between negative 1 and 1? Okay, so now you know what happens, right? If it was above 1, is that right? Or if it was below negative 1, you know it wouldn't happen, right? So let's do this here. So let's do these individually here. So cosine of theta is equal to negative 1 plus root 3 over 2. So again,
What is the concept here?
solving equations. So you're solving for, like in algebra, we solve for x.
Oh, it's cosine of theta because that's the
And let's do this here. Sorry, we are running out of time here, so let me actually stop here. We'll finish up 5-1 on
16.5.
Friday.
Your chairs on.
Oh, sorry.
Mr. Honda,
Yep.
is that not the end of the 6.1?
No.
There's more.
Yeah. So I'm not gonna sign 6.1. You guys can probably start on the homework. You guys will probably start on the homework. You won't be able to finish it off. So you can actually get to the quadratic formula questions if you wanted to start.